Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going over section 7.6, Polynomials. Now this is where we finally step away from the arithmetic of things and start working back in the world of algebra. Now polynomials are very, very special. Polynomials are the thing that you work with from now until the end of mathematics. A lot of the stuff that we deal with deals with polynomials and also the arithmetic that we've learned so far. So we're finally getting into some of the really heavy conceptual stuff from Algebra 1. So let's look at what a polynomial is. To begin with, let's dissect the word. The beginning portion says poly, and poly means many. A polygon is a multi-sided object. A polytick is a multiple blood-sucking arachnid. Weird. And here I thought polyticks was not aptly named. And on the other side, we have nomials. Nomials means numbers. So a polynomial will be a number in multiple parts. It will be a single number represented by multiple portions or multiple parts for that specific number. Mainly because we're going to be dealing with, you guessed it, variables. So polynomials are numbers in multiple parts. The first one is called the monomial. Mono meaning single, and nomial meaning number. So a monomial is a single number. Now, monomials always occur in a linear fashion, meaning that, well, not linear fashion, where the exponent is never on the denominator. So please note that for all of these, I'm going to put that over here, note, for polynomials, the variable is never on the denominator, or I should say in the denominator. If it ever is, it's no longer a polynomial function. It might be a polynomial function in the denominator, but the whole thing is not polynomial. Okay, so a monomial would be a single number. What do you think binomial means? Well, let's think of some other things that start with bi, like bicycle. Bicycle is a device that uses two wheels. So a binomial would probably mean two numbers. So bi means two, nomial means number, so this would be two numbers. And I think you would like an example of each, right? A monomial would be something like 2x, or 4x squared, or 1/3 x. Oh, there was a fraction there, but the variable is not in the denominator, so it's just fine. Which means that we could also have something like negative 0.025x. All of those, x to the fifth. All of those would be examples of monomials. A binomial is a number in two parts. The two parts are always separated by addition. So an example of a binomial would be x minus 4. X squared plus 25. 3x plus 12. All of these are binomials. They are numbers in two parts. So what about a trinomial? Well, let's think of something that has tri in it, like triforce or tricycle. Well, a triforce is a triangle, which is three angles. A tricycle is basically a bicycle with three wheels. So this would be three numbers. And some examples of this would be x squared minus 2x plus 1, or 4x squared minus 13x plus 25, or 5x to the 52nd minus 21y squared plus 15z. These are all examples of trinomials, a number in 3 parts, separated by addition. Okay, and then of course after that would be poly, which is many numbers. I'm not going to go into anything greater than trinomials. Not for this course anyway. So the next thing we need to learn about is finding the degree of a polynomial. So let's look at it. Degree of a polynomial. The degree of a polynomial is the highest power of its exponent. The degree of a polynomial is the highest power of its exponent. So let's look at this binomial of 4x squared minus 25. What is the degree of this binomial? Well, its highest power is 2, so the degree would be 2. It is a second degree polynomial. All right, let's look at another one. Let's say we have x to the 25th minus 5. Well, what's the degree of this polynomial? Well, its highest power is 25, so its degree would be 25. And how about a trinomial with x squared minus 41x to the 5th plus 12x to the 32nd? Well, 32 is the biggest power, so the degree is 32. Now we have special names for polynomials of different degrees. And I'm going to make a little chart, and we're going to copy down the chart because the chart actually kind of means a lot. So let's start out with the chart. We're going to have degree, and we're going to have a name, and then we're going to have an example in standard form. Now, standard form means that you go in descending order of power. So if you have like an x to the 5th, then you'd have something x to the 5th, something else x to the 4th, something else x to the 3rd, something to x to the 2nd, something x, and then a constant. So on all of them, you'll note that the power decreases by 1 every time. So it's in descending order of power. So degree 0, this one is called the constant. And an example in standard form of a constant would be 1. Yeah, 1's a constant. It's really boring. Constants are always boring because they never change. It's always the same, over and over and over and over again, kind of like Scooby-Doo movies. Degree 1. This one is called linear because it creates a straight line when graphed. And an example of a linear would be x plus 1. Yep, that easy. What about 2? Now we're going into an area where things are changing quite a bit. No longer are we dealing with straight lines, we start dealing with things that have curves. This is called a quadratic. And an example in standard form would be 2x squared minus 4x plus 5. And then we have 3, which is cubic. And an example of cubic would be x cubed plus 2x squared plus 3x plus 4. And then 4 is called quartic, which again would be something like 2x to the 4th plus 3x to the 5th plus x to, 4, that should be 3, 2, 1, and 0. And then the last one that we're going to go with that actually has a special name is called the quintic, or 5th power. Don't worry, that'll be on your test. So this will be something like 3x to the 5th minus 4x to the 4th plus 2x to the 3rd minus 5x squared plus 2x plus 50. Note that in standard form, you're always going from your highest power of x, or your degree, downward by 1 every time. Okay. Give you a few more moments to write that down, and then we will move on. All right, we're going to do a couple of examples, and then we're going to call it a day. Our example is going to be classify according to the degree. And the first one is going to be 5x minus 6. This classification would be linear because it has a degree of 1. How about y squared plus y minus 16? This one would be quadratic because it has a degree of 2. And then let's try something ridiculous like 6y to the 7th plus 5y to the 5th minus 21. This would be a 7th degree, and it doesn't have a name, right? We stopped special names at 5th degree at quintic. So its special name is 7th degree because after 7th we just kind of ran out of words to use, or they got really weird because we were using Greek, and it is all Greek to me. All right. And that's about it, to be honest. That's usually how things work out. It's pretty simple. We're just classifying them for now. In our next section, we'll learn how to add polynomials. And then in the following section, we will learn how to multiply them. And that one is actually going to take a little while. So, yeah, we're going to take a couple of days on one of these subjects. Okay, now it's time for the before you go work. Bug work time. This is, of course, section 7.6. In which case we're dealing with polynomials, so hashtags, polynumbers for homework. Our homework is a polynomial. Math is awesome. Let's go with 1 through 25 odd. And then do 29, 33, 35, 39, 41, 45, 47, oops, forgot the 7 there, 49. Mr. O'Neill, this is too much. No, it isn't. If you guys haven't noticed, all the homework this chapter has been super easy. 51, except maybe the last section. 55, 59, and 61. All right, good luck and have fun.